Hello dear students, this is grade 12 mathematics lesson on unit 3 introduction to differential calculus. On today's lesson we focus on the chain rule and higher order derivatives. So after revising this lesson you are expected to apply the chain rule to find the derivative of composite functions, and you are expected to find the higher order derivative of functions. Now let's continue to the lesson. Now if g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x with f of g of x, or fog of x derivative, is given by the derivative of f of g of x times g derivative of x. Now let's see the proof of this theorem. Proof: fog derivative of x, this will be equal to the limit of this function at x plus h minus the function, this function divided by h, where h goes to 0. Therefore this function at x plus h means this simply it is f of g of x plus h. By the way, fog means simply fog of x. This is equivalent to this f of g of x. Therefore f of g of x derivative equal to this f of g of x plus h minus f of g of x over h, where h goes to 0. Therefore from this I can write this expression in this form: f of g of x plus h minus f of g of x over h. Simply I multiplied by this g of x plus h minus g of x, g of x plus h minus g of x. Just I multiply by these two and arrange this h to there, and g of x plus h over minus g of x. I have also g of x plus h minus g of x here. So from this the limit of this expression, to find the limit of this expression, will be t simply f derivative of g of f derivative of g of x. Let's see how this obtained. And the limit of this one is simply the limit of g of x plus h minus g of x over h, where h goes to 0, is simply this g derivative of x. Therefore the composition of this function f of g of x derivative will be this f derivative of g of x times g derivative of x. But let's see how this obtained. To find that, let's assume this one to be k, g of x plus h, g of x plus h minus g of x minus g of x to be k. We assume this. Now from this I can find g of x plus h. So g of x plus h will be this k from this g of x plus h is equal to this g of x plus k, rearranging this. So this expression will be, it is f of g of x plus h will be, it is f of g of x plus h, it is g of x plus k minus f of g of x, f of g of x divided by g of x plus h minus g of x, we assume to be k. So the limit when h goes to 0, I can see here, when h goes to 0, this will be this g of x minus g of x. So k will also goes to 0. So the limit of this expression, the limit when k goes to 0, the limit of this expression f of g of x plus k minus f of g of x over k, where k goes to 0. This means, assume this as single number, this f of x plus h minus f of x over k, similar to that one. So this means it is the derivative of f of this part, f of g, f derivative of g of x. Therefore, this part will be this f derivative of g of x, and the next part will be this g derivative of x. So this complete the proof. So we will have this one. This part will be this f derivative of g of x times the other part will be this g derivative of x. So this completes the proof. Now let's continue to the other part. Before that, this composition, the derivative of composition function can be extended for 3 or more function. For 3 function, if we have 3 function, f of g of h of x derivative can be evaluated like this. The derivative of composition of 3 function, f of g of h of x will be equal to this f derivative times g of h of x times g derivative of h of x times h derivative of x. Now let's see example for this. Let f of x is equal to the square root of 4 plus x squared, and then we are asked to determine the derivative of the function and the derivative of the function at 2. Look this function. This function is, it is a composition of the function, the square root function and the polynomial function. So assume this g of x to be square root of x and h of x to be the internal function 4 plus x squared. So when you compose these two, you get this one. So g of h of x gives you this. Therefore here our f of x, the given function, will be this, the composition of these two functions, g of x and h of x. So f of x equal to g of h of x. So this implies, using chain rule, the derivative of this function will be equal to g derivative of h of x times h derivative of x. So this equal to g derivative, the derivative of the square root function, square root of x. The derivative of square root of x is 1 over 2 root x, but it is 1 over 2 root x. You put h of x in place of x, so you have, for this case, it is 1 over 2 root of the internal function. It's not x here, it is 4 plus x squared. Therefore 1 divided by 2, the square root of 4 plus x squared times h of x. Our h of x is 1, its derivative it is 2x. So simply, if you face a composite function, what you do is, look this one, we have this expression. So the first expression is square root and second one is a polynomial. So take the derivative of the square root expression. So the square root of x is 1 over 2 root x. So the derivative of this expression, or square root of 4 plus x squared, first it is 1 over 2 root 4 plus x squared times the derivative of the inner function. The derivative of the inner function is 2x. So this is the answer. Now let's see another example. So simplifying this, 2 by 2, you get x over the square root of 4 plus x squared. Now let's continue to the next part. Okay, now we are also asked to find the derivative of this function at 2. The derivative of this function at 2. Therefore, since we have found the derivative of the function to be x over the square root of 4 plus x squared, putting 2 here, you will have this one, 2, f derivative of 2, this equal to this, 2 over the square root of 4 plus 2 squared. So this equal to 2 over the square root of 8. The square root of 8 is 2 root. So simplifying this, you get 1 over the square root of 2, and rationalizing it, you get the square root of 2 over 2. Second example, we have this one. Let y is equal to e raised to the square root of x squared plus 5x plus 4. Then you are asked to find dy by dx. So here you can see that we have 3 functions. This is the composition of 3 functions. First, the exponential function e raised to x. Second, the square root function. And then the inner function, polynomial function. So applying the chain rule, we'll have this one. Dy by dx, this equal to e raised to this part. I hope you remember the derivative of e raised to x itself. So assuming this as a single, e raised to y, assume this is the derivative of this one itself first. So e raised to itself, the square root of x squared plus 5x plus 4 times, and then applying the chain rule, the second function is here. It is the square root function, the square root of x squared plus 5x plus 4. So the square root of x squared plus 5x plus 4's derivative is this 1 over 2 root of this one. You remember the derivative of the square root of x is this. It is 1 over 2 root x. Therefore, here, assuming the inner part to be a single number, the square root of y, the derivative of square root of y is this 1 over 2 root y. Therefore, it is 1 over 2 root y. We assume y to be this x squared plus 5x plus 4 times, then the third function is the inner function. It is x squared plus 5x plus 4. So the derivative of x squared plus 5x plus 4 will be this 2x plus 5. So this is the answer. I can rewrite this in this form. We have this e raised to the square root of x squared plus 5x plus 4 times the product of the two will be this 2x plus 5 over 2 times the square root of x squared plus 5x plus 4. Now, let's see another example, third example. We have this one. Let f of x is sine of the square root of ln of x squared plus 7. Here we have 4 functions: sine, the square root, ln, and polynomial. 1, 2, 3, 4. We have 4 functions: sine function, the square root function, ln, and the polynomial. So applying the chain rule, you will have this. So the first one is sine function. The derivative of sine is cos of this one itself, times the second function, the square root function. The derivative of square root function is this, the square root of x, 1 over 2 root x. So applying that, the square root of this is this 1 over 2 root of this, 1 over 2 root of the square root of ln x squared plus 7 times the next function is ln. The derivative of ln x, I hope you remember this. If we have ln x, its derivative is 1 over x. Therefore, the derivative of ln of x squared plus 7 is this 1 over x squared plus 7 times 1 over x squared plus 7 times the other function is this, the inner function x squared plus 7. The derivative of x squared plus 7 is it is 2x. So this is it. Then rearranging this, you'll have this one. The derivative of the function is equal to, simply you can just cancel 2 here, cancelling 2, multiplying x by this. So you have x cos square root of ln x squared plus 7 divided by this part, simply it is x squared plus 7 times the square root of ln x. So this is the answer. Now let's see higher order derivatives. Higher order derivative. The second derivative of a function f is denoted by this one. It's denoted by this, and it is the derivative of the first derivative. So second derivative of function, which equals to, it is the derivative of the first derivative. We say that f is twice differentiable if this limit exists, which equal to the second derivative of a function is equal to the first derivative of function at x plus h minus f derivative x over h, where h goes to 0. If this limit exists, then the function is twice differentiable. The nth derivative of f is, it is denoted by this symbol, the nth derivative of a function x, and it is defined as the nth derivative of function is equal to the n minus 1 derivative of x plus h minus the n minus 1 derivative of x divided by h, where h goes to 0. If this limit exists, we say this function is n times differentiable. We say n times differentiable. The higher order derivatives are obtained by simply repeated differentiating a function. Simply you differentiate a function repeatedly to find their higher order derivative. Now let's see one notation. If y is f of x, then we write the nth derivative of function in this form, or in this form dny by dxn, or I can write in this form dn of fx by dxn, or using this notation capital D of n of f of x. So these all are simply, it means that the nth derivative of a given function. Now let's see example. Let f of x is given to be x cos x, then we are asked to find the second derivative of this function. F derivative of x means it is x cos x derivative. So applying product rule, we can find the derivative of the expression, the first derivative of the function, equal to this x derivative times cos x plus x times second function cos x derivative. So this equal to the derivative of x is 1 times cos x. Derivative of cos x is this negative 1. The derivative of cos x is this minus sin x. Minus sin x times x is minus x sin x. So this is the first derivative. To find the second derivative, take the derivative of the first derivative. That means it is cos x minus x sin x derivative. So this equal to the derivative of difference means you can differentiate individual functions. Therefore, cos x derivative minus the derivative of this will be, it is x derivative times sin x plus x times sin x derivative. Okay, so this will be equal to the derivative of cos x is this minus sin x minus the derivative of x is this 1 times sin x plus x times the derivative of sin x it is cos x. So simplifying this, you will have this 1 minus sin x, and minus sin x you will have this minus 2x, minus times x cos x is minus x cos x. So this will be the second derivative of this function x times cos x. Now let's continue to the next example. Here we have a function f of x is equal to x times e raised to x, and we are asked to find the nth derivative of this function, dn of fx by dxn. So to find this, let's try to find the derivative repeatedly. Let's start from the first derivative. The first derivative of this function, this equal to x times e raised to x derivative, applying product rule, x derivative times e raised to x plus x times e raised to x derivative. So this will be the derivative of x is 1 times e raised to x plus e raised to x derivative itself, e raised to x times x. You'll have this one. So the first derivative of this function is this e raised to x plus x times e raised to x. And writing this in other form, factoring e raised to x outside, you'll have e raised to x into 1 plus x. Let's try to find second derivative of this function. The second derivative of this function is equal to the derivative of the first derivative. We have the first derivative here, e raised to x plus x times e raised to x, so you differentiate that. So the derivative of this will be the derivative of the first function, e raised to x itself, plus applying the product rule, or simply we have found the derivative of x times e raised to x here. X times e raised to x is this one, e raised to x plus x times e raised to x. Therefore, this is equal to the derivative of e raised to x itself. The derivative of this one, it is e raised to x plus x times e raised to x. Simplifying this, you will have this one, e raised to x plus e raised to x, it is twice of e raised to x plus x times e raised to x. Again, factoring e raised to x, you will have this one, 2 plus x. Now again, let's continue. Let's try to find the third derivative. The third derivative, you differentiate the second derivative. The second derivative is this one. So 2 e raised to x plus x times e raised to x derivative, this equal to the derivative of this part, it is 2 times e raised to x plus the derivative of x times e raised to x. Simply we have found this result there, x times e raised to x, it is e raised to x plus x times e raised to x. Therefore, this is equal to this 2 times e raised to x plus this part will be this one, e raised to x plus x times e raised to x. Therefore, when you add this, you get 2 times e raised to x plus e raised to x, it is 3 e raised to x plus x times e raised to x. Again, factoring e raised to x as a common, you will have this one, e raised to x times 3 plus x. So when you see the pattern for the first derivative of x, you will have this one, e raised to x into 1 plus x. For the second derivative of this expression, you will have this one, e raised to x times 2 plus x. For the third derivative of this function, you have this one, e raised to x into 3 plus x. As you can see, all are the same except the numbers 1, 2, 3. So for third derivative, it is e raised to x 3 plus x. For the first derivative, 1 plus x, e raised to x 1 plus x. For second, e raised to x 2 plus x. For third, e raised to x 3 plus x. So for the fourth, it will be simply we can see the pattern. It will be this e raised to x times 4 plus x. So for nth derivative, the result will be e raised to x times n plus x. Therefore, the nth derivative of this function will be this e raised to x times n plus x. To summarize what we have seen, 1, if g is differentiable at x and f is differentiable at g of x, then f of g of x is differentiable at x with this. It's a chain rule. For f of g of x derivative means f derivative of g of x times g derivative of x. This is the first concept that we have seen today. And we have also seen their order derivatives of a function. Simply it is obtained by differentiating repeatedly. To get second derivative, you differentiate the first. To get the fifth derivative, you differentiate the fourth, and so on. So this is all about today's lesson. For you, I'll give exercise. Please try these questions. So it will be enough for today. I'll see you on the next lecture. Until then, goodbye.